Hello. Sorry.
Hi, Ernest.
All right, so for those that don't know me, which I think everybody here does, maybe you don't know me, I don't know. My name's Ernest McCracken. We have a group called Memphis Game Developers, and we do workshops every Wednesday, or once a month we do workshops. We also do game jams. We work on various projects and learn from each other and just trying to make games. We have a VR lab upstairs. We also have a game development co-work spot on Union Avenue that we hang out at a lot and do open houses there as well. It's a pretty cool spot. So today I'm going to do a talk on procedural generation. So I actually have a couple slides, and then I got I'll show some demos. And then maybe if we have time, we'll build on top of them. I didn't code too much just because I wasn't really sure how much time we'd have. I'm really bad at judging time taken for these types of things, so you'd think I'd be better at it since I teach, but no. So procedural generation is the idea of developing, or I should say, creating content algorithmically. So one way to create content, and we call it static content, is to have artists actually make stuff, 3D models and really fancy props and sound effects and everything else in your game. And this is kind of the traditional way of building games, and especially if you want really nice looking games. But a lot of companies or studios simply don't have the budget to either don't know any artists, like most of us, or they can't afford artists, or we want to be able to create something that's almost like infinite terrain, something that's procedural and has a lot of replayability. So we can actually create our content using either nothing but code or even a combination of code and art assets. So it's essentially random generation. And I'll probably say the most common way of using it is textures and 3D models. But that's not the only use case, and I'll show a little example here. So this way you can create large amounts of content, also give a lot of replayability. Probably the most famous kind of infinite terrain game that I can think of is probably Minecraft. And one part of Minecraft is simply just people that they create a game and they get some interesting terrain, and people want to just see that by itself. Can be kind of cool. So we use procedural generation. There are some advantages of it. Since we're creating everything on the fly, it actually gives us smaller file sizes because we don't have these massive meshes and textures saved to our disk. Now, there's two ways. We could procedurally generate everything while we play the game, or we could procedurally generate stuff during our design time to kind of help us. Like if you just have a very large open world and we don't want the artist to have to create it all from scratch, we can procedurally generate some base terrain and save it to disk, and then let the artist go in and touch it up. So something like that, you're still creating something that'll be saved to disk, which will be loaded to your final game. Then the other way, of course, is during runtime, and that would result in smaller file sizes because you simply don't have anything initially. You're creating it all as you play the game. And I mean, file size can be, it's not as big of a deal these days, but it still can be kind of cost prohibitive. Like I think Arc is the biggest game I've ever seen. It's 66 gigabytes. And probably I would imagine that a large portion of the terrain on that game is actually procedurally generated during their design time. But when you join an Arc game, it's the same map. And so it still has a large file size. One of the other advantages is just the replayability, of course. And then the two big genres it's used a lot in is roguelikes. Roguelikes heavily for the randomness and the replayability. And then survival games for the openness, to be able to just have this infinite world that you be able to travel. So one of the oldest procedural games is Dwarf Fortress. It's just ASCII, but it's incredibly in-depth game, kind of a worker assignment RPG strategy survival game. It's been worked on forever. Then you got Minecraft, of course. So you have infinite what we call voxel-based terrain, which I'll talk a little bit after, maybe after the demos about voxels. But voxels is a whole nother subject, which it's all related, but there's a lot of other additional components to go into voxelization. Fractals are procedurally generated, so this is more of just a kind of abstract art concept. Procedural materials. So here we have procedural textures to create wood grain effects, or wood effects. That way we can generate multiple types of wood without reusing the same texture. And then we can also fine-tune parameters. So every time we pick up a piece of wood, it'll look slightly different from every other piece of wood that we picked up. Dungeon generation. So this is also procedural. So each one of these, and this could be where everything is procedurally generated, or maybe it's just the layout. There's a Unity asset tool called Dungeon where you actually design the room itself for the most part. There's a little bit of randomness that goes into it, but your artist will go in and actually design a large portion of the actual rooms, and then Dungeon will put them together to form a dungeon and add some randomness to the rooms as well. Change props around. So these dungeon generators can be very useful for, like games like Diablo. So you can replay the same dungeon over and over, and you don't know exactly where to go in the dungeon. You still have to kind of explore around. Procedural buildings. There's a Unity tool called Build R, and again, you give it some indication of what the building could look like. I think this one you actually give it like some of the textures. You say you give it information about what type of trim and the windows, what type of windows it might have, and balconies and so on. And then it will procedurally generate a building for you. And each one's going to be different every time. So you'll have slightly different buildings every time. And it'll actually do interior layouts as well. It's a pretty complicated tool. I've used it a couple times. It's pretty in-depth. It's a whole talk in itself of learning just that one asset. So once you design your buildings, you can then take those and put them inside a city generator. And this will generate streets and buildings and give it a layout such that it is like what we would normally see as a city, where you have more of the skyscrapers are in the middle, and then it's surrounded by the metropolitan area, and you can even have it kind of break out as it goes towards the outskirts. So each one of these buildings could have been built with Build R, and then you put in the city generator, and now you have this giant city that you can walk around the buildings with, and then have like a GTA-like game or something like that. So, and not just graphics, but even text, procedural text. there is a website called Seventh Sanctum, which is name generators and description generators, all types of word generators. And it can generate these what they call writing prompts to give you sometimes really interesting descriptions of characters. Unfortunately, the guy that makes Seventh Sanctum, anything that's generated you can use for whatever reasons, but he does not give the code away, unfortunately. But it is a pretty cool resource for, let's say you want to have NPCs in your game and you want to be able to generate them right there. You can grab random descriptions of your characters here without having to have a writer write each description. Especially if you have a fully procedural game, then you would need something like that. Okay, so this talk I'm going to focus on. Hey, how's it going? Yeah, we moved to 226 because they're preparing an event for 225 in the morning.
They got food over there.
They do have food over there. Unfortunately, I wish it was for us. Maybe it is. I don't know. Maybe I should see if Cody brought that for us or not. So procedural generation, there are a lot of different algorithms for a lot of different things. Anything you can think of, you could take parts of, think of like the weapons in Borderlands, those are procedurally generated. But there's different algorithms for different types of generation. We're going to focus on terrain generation because it's very widely studied and a lot of people have done it and there's a lot of tutorials out there on how to do it. And it uses a pretty simple type of noise generation. So it all comes down to noise functions. When I say a noise function, it's essentially randomness, entropy. But not all noise is the same. So off to the left we have random noise. You're essentially your white static noise that you might see on the TV. Completely random. Then next to that you have Voronoi or Voronoi noise. Then next to that we have fractal noise, which actually is used a lot for generating map terrain. And then next to that we have Perlin noise. And Perlin noise is used quite frequently for generating terrain. Now the fractal noise is used for map terrain, and what I mean by that is very blown out views of terrain, where the Perlin noise is used for that as well, but used for terrain that you would walk across. And the differences here are, you have the random noise. The Perlin noise, now I don't know how to describe Voronoi or fractal noise. It's all, of course, there's mathematics behind it. But the difference with Perlin noise is that it is essentially just random sine waves. Remember, sine waves are just this. So it's just random sine waves. So with that, we can generate stuff that kind of looks like terrain. Generally what we do is we'll generate a sine wave with a certain scale to it, and then we'll add another sine wave, another Perlin noise pass with a smaller scale and a smaller scale and a smaller scale. And then we can also subtract or take the maximum or do whatever operations to give us this terrain. So the first one here is 1D Perlin noise. This is essentially just changing one parameter, which is our x value, and then we're going to generate a height value. So if we were developing a 2D game, even though this is called 1D, just because it's just one variable that changes, if you're making a 2D game, you would use 1D Perlin noise. Do I have any markers here? Oh, I do. Cool. I can draw a couple examples too. Let me see here if I can draw a quick one. So we might have, let's say we have I'm going to do a kind of quick example of 1D Perlin noise. So let's say we have, that's kind of so let's say we have one pass that generates something like that. And then we can make a second pass. So this has a certain amplitude as well as a certain scale, which is how it's stretched out. So we can compress that scale and do another pass where we generate something that's more like this. Actually, let me do that over again. So this is our first pass. And then we might have to do a second pass, which is, this is really hard to draw. So something like this, we basically this is a much bigger scale, as you can see. We compress that down, and we also give it a smaller amplitude. And so when we add these together, we would get, and I'm going to try my best to attempt this, but something like that. And that's how we get our terrain. Because if you look at it, you could kind of abstract this away, or have that model some 2D terrain. Now, so that's 1D Perlin noise. And then 2D Perlin noise is just adding another variable to that. Yeah, I'm blowing up here. Okay, so for 2D Perlin noise, we have, we move in the X direction and in the Z direction, and then we figure out the height. So really, the 2D Perlin noise, which is at the bottom here, is really just this, but extrapolated out in a second dimension. And we get a height map, what's called a height map, here. That's what we generally use for any kind of standard terrain. Because, I mean, for a 3D game at least, we would use something like that. Now, we can go beyond that to go to what's called 3D Perlin noise. Now, the problem with 2D Perlin noise is that since it's sine waves, we can only generate a height map. One of the problems with a height map is we don't have overhangs. Like you were just saying, it's not a function. So with the 2D Perlin noise, we can't generate overhangs, we can't generate caves, we can't generate cliffs that, again, have a overhang or something like that to them. With 3D Perlin noise, we can do that. So you can see with 3D Perlin noise, what it's actually doing is we're taking X, Y, and Z, and then we're generating what's commonly known as a density value. We're saying, what is the density at that specific point? So with X, we can generate a height value for 1D. For 2D, we generate again a height value for X and Z. And then for the 3D Perlin noise, we take X, Y, and Z, and we generate the density. And so here we're seeing density values in a volume. Now, normally you're not going to generate your terrain with just this. Usually you'll generate the 2D Perlin noise, and you'll use what they use is called Perlin worms. And so they use 3D Perlin noise to figure out where essentially a mining worm goes, and it digs out a cavern as it kind of goes around and splits off and does this little thing. But with 3D Perlin noise, you can generate something that's not a height map. You can also use it to generate other things. Maybe you want to use it to generate like heat values or the density of the air, pretty much anything you want. Okay, so this is what's going to give us our values, basically our point values of where the surface is. And we're not going to do any 3D Perlin noise because that's pretty complicated and it's beyond the scope of this. But we will do 1D and 2D Perlin noise. So that value that it produces is where a point on the mesh that is the terrain. I'm going to show some demos, but we're not going to build meshes because it does involve a lot of code. But I do want to show you, just kind of briefly describe the process of building meshes. That way you can kind So in Unity, it uses what's called the mesh filter. The mesh filter is just a component, and really it's just the data for a mesh. This contains all your geometry. And you can see there's only one parameter there, and that's the actual mesh, the asset that you load. So how is meshes represented? So at its core, it's just a list of points, x, y, z. Each one of those points is a vertex in the mesh geometry. And they're called vertices, those points. However, we need more than just those vertices to describe the mesh, because we have to describe the faces of the mesh as well. So mesh faces are basically, they're a list of triangles that specifies the face of each mesh. Because the thing is given just the points, we can't infer how those points are connected. We have this long list of points, and I mean we can draw a line between all those points, and we would just get one line that goes throughout our entire mesh. So the triangles tell us which sets of points are connected to form a triangle. Now we also need something called normals. And actually we don't need the normals, but they are going to make the mesh look a lot better. So the normals basically tell which way is that face pointing. Is it pointing this way? Is it pointing that way? And it's used for shading and lighting. It gives those systems information about how light will bounce off that face. The very last thing we'll need is what's called UV coordinates, and I'll show those in the code here. It basically just says how does a texture wrap around that mesh. So just a little bit of code here. We're just building a very simple quad. So we have an array of vectors. A vector 3 is just an XYZ coordinate, XYZ point. And then we're going to build a quad out of it. So we have one at 0, 0, 0. Here, I can actually draw this. So we have a point at 0, 0, 0. And then our next point is at x1. So we'll say that this is 1. 1, 0, 0, x, y, or x, z, and y direction.
I'll draw it in space, that'd be cool.
So what?
I'll draw it in the space here, that'd be cool.
Oh, yeah. I'm going to get one of those 3D printer pens. You can draw outwards. So the next point is at 0, 1. 0. So this is, we'll say this is point 1. This is 2, 3. Because these indexes, actually, sorry, this is 0. These indices actually matter, because these essentially identifies that point in the list. And then our last point, of course, is 1, 1, 0. Now, we're just generating essentially a 2D quad, and if we had a cube, we would have another set of points that would come out. So 0, 1, 2, and 3. And then we'll have a mesh object, and we just set the property of that mesh, of those vertices, to our array. So the next thing we need to do is actually build. We have a mesh object. We have to give it the vertices. We have to give it the triangles and normals and UV coordinates. These are all just arrays that we have to set in order to build a mesh. So we have a quad, and
you have the edges, but not the vertices, the edges, but not the faces.
Yeah, because the thing is, if we would just draw this, it would essentially go like that. Right. We don't know, just by these points, we don't know that these are connected.
Right.
Nor do we know that these are connected. So the triangles tell us those connections. Now, a quad, since it's using triangles, we actually this will be 2 triangles for this quad. And so to give the triangles, the faces, we have to give it the vertices. So 0, 2, and 1 So we have this array called trie, and 0, 2, and 1 are lower left triangle. So 0, 2, 1. So that's here. I can use another. Got multiple colors here. So we have 0, 2, 1. That's one triangle. And then 2, 3, 1 is our other triangle. 2, 3. Whoops. Yeah, 2, 3, 1. And then it infers that this is closed off. You only have to give it the 3 corners. We don't have to tell it that to also add 2 again, because it knows, because it's a triangle. It's only going to have 3 points. So, man, that one marker was really strong. So now we have our 2 faces.
Got a question.
Yeah.
I might be jumping ahead here, but does it matter what order we stick those triangles, or the points in the triangle grouped together?
I could have swore I read that it does.
It has something to do with mesh topography and why you would.
Yeah, I think it's really just the way we describe the points. Now yeah, you could be right. It has something to do with the mesh topography, but I don't know the exact specifics of why for that. And then we have to go over our normals. Now, it's just a quad. So all of our normals, depending on which way the face is, all of our normals are either going to go inwards or outwards. And we have to give one for each point, so we can say that's in, and in. So those are just saying vector 3 forward and take the negative that. You could also say vector 3 back. Either one. And we set that as the normals. Finally, we do our UV mapping. So the UV mapping determines how a texture wraps around the mesh. So it basically takes the mesh and flattens it out. And then that way the texture can be drawn onto it. So these coordinates, for a quad, it's fairly simple. It's really just those points on the quad. So this type of code is something that you would have a lot of iteration doing if you're doing something like Minecraft, where you're drawing blocks, because you're going to be drawing a bunch of quads at each face. And if we have time, I think I have my voxel code on here. We could take a look at it. But so that's all that's needed to procedurally generate a mesh during runtime. Now, normally, if it's a static content, you're just loading that mesh into the mesh filter, but you can do all this from code. Any questions so far?
So the mesh normals, they just tell you which side of the mesh you're going to be putting the texture on?
They tell the shader what, because you got to think, so let's go back to this picture here. How do we know which side of this dolphin should be shaded? Is it the inward, the side on the inside, which we know is not the case?
Not shaded on both sides.
Yeah.
By shaded, you mean from an external light?
Yeah, from an external light.
You won't see it if the normals are actually pointing in the wrong direction.
Which I'll show you here in Unity. And the reason that is we don't do both sides is because if we did, then that's twice the amount of rendering needed. But if we can if we can just say only do one side of this, then regardless of what the scene is, we can cut the amount of rendering in half, of polygon rendering.
It's not rendering the right side of the dolphin if you're only looking at the left side. Is that what you're saying?
It's not rendering the inside of the dolphin. If our camera was inside of it, we wouldn't see anything at all.
Gotcha.
Yeah.
That's why it'd be like float inside of a video game.
Yeah. When you clip through a wall, you can just kind of see through the other wall behind it.
Well, the other reason is you have to think that these are actually not thick. They
Yeah.
have no literal thickness on them.
So let me bring up Unity, and we can play with some Perlin noise. So the first one I'm gonna do is just this Perlin 1D noise, and actually have a prefab for it. So all I have here, since I'm using 1D Perlin noise, I'm using a line renderer, but you could easily do this on a mesh as well. Create like a flat mesh, or create a flat mesh and then pull it back a little bit. That way you have a full 3D mesh. So we have our line render, which is just describing this line, and it has points on it. And normally you would have to set each one of these points, but I'm going to do it from code because that's the point. And you can see I have this is my script right here. So, and if you look at it, we have the parameters we have. I have the length, which is the length of the line. How many steps am I going to generate a point? So it's 0.5. So I'll have 200 points. If I use a step of 1, I don't have 100 points. I have my scale, which remember we're going back to here. The scale is just determining how stretched out or compressed our noise pass is going to be. And then I have a multiplier, and the multiplier is just the amplitude. You know, how big is it? So normally when your first pass, when you generate your base terrain, you're going to have one where you do have a large amplitude, and it gives you this kind of rolling hills, very smooth rolling hills. When we add our roughness to it, we want that to be very small, because we want that to just be, we don't want the roughness to, change this dramatically. We just want to add roughness to the terrain itself.
And as far as steps go, I suppose you could think of that as sort of like the resolution.
The resolution, yeah. So let's look at this script right here. So Unity offers a function called purlin noise, which helps us out a lot. Say again?
Can you make that bigger?
Oh, yeah. Is that a little better? So I have my purlin 1D. I have two functions here, and they both do the same thing. The only difference is this one's going to generate a simple, it's going to be one pass of the purlin noise that's going to generate our line. The next one is going to take that line and add another pass of purlin noise to it. So that way we can do multiple passes and then determine what we want to do. So let's look at this. So all I'm going to do is I'm going to count, I'm going to start from 0 and count all the way up to length and generate a point at each step. So I'm going to start at 0. Now, Unity's purlin noise function always takes two parameters. It's 2D purlin noise. However, if we want to do 1D purlin noise, we just keep one of those values constant. So it takes an X and a Y, or X and Z, or X and Y, whatever you want to call it. And we just keep one of them constant, and we only change the other one. So here, I'm just going to create a random constant to be the one we don't change. I have to set the points on the line render ahead of time, which is this right here. This has to be created ahead of time. So I go ahead and this keeps track of what point I'm on. And the line render, I'm just going to say the position count, this is what I have to set initially, is the length divided by step. That'll give me 200 points. So at that point, we start at the start value, which is 0. And as long as this value is less than length, we're going to keep going. And then here, we're going to add step to the start value. We're going to add 0.5 to it every pass. And all we have to do here is grab a sample. We call math f purlin noise. And there's a little bit of math right here. So what I've taken is I've taken the start value and I divide it by length, which will just give me generally values from 0 to 1. Because start's always going to be less than or equal to length. You can give it values greater than 1, but I like to keep everything kind of normalized. So start divided by length and then multiply it by scale. So the larger my scale values get, the more it's going to squeeze, I believe. So at very low scale values, I get this kind of very stretched out rolling hills. And then for the random, or for this right here, this is always going to be constant. This doesn't change. This random constant does not change. That gives us 1D Perlin noise. One thing you have to do, and this is just because this Perlin noise function, it's guaranteed to give values 0 or greater, but not necessarily less than 1. It's supposed to give you a value from 0 to 1, but according to the Unity documentation, it can give you a value greater than 1. And so they recommend clamping this from 0 to 1. Then I'm going to take that value, so that's going to give me a value from 0 to 1, no matter what. Then I'm going to take that value and I'm going to multiply it by our multiplier. And then I'm just going to set that in the position of that line. So I'm going to add a new point to the line render at position start, x start, y equals sample, and then z equals 0. Now we could take this and then do something weird with the z value, but we're not going to do that. And then we add 1 to our point count so that this will increment, and then we increment our start value. So let's do that real quick. We'll start with a length of 100, step 0.5. Let's start with a scale of 4. Multiplier, we'll keep it at 2. Oh, something I didn't mention right here, context menu. This adds an option to run this method when this adds a menu to the context menu when I click on that component. It's very handy because now this way I don't have to run this. I don't have to run the game. I can actually generate something by just right-clicking and go to Generate Simple. So I can do that because of this right here. Incredibly useful. So let's do a Generate Simple. And what happened to our line? Oh, there it is. So our line is very small. So let's add to the multiplier. Let's do 5. Actually, let's do 10. Let's do 20. So there you go. This is a random sine wave, very smooth. So we want to add on to that.
So it looks like it's 4 sine waves, the number that is the scale, right?
You might be right there. 1, 2, 3, 4, 5. 6. It does increase the number of waves. Maybe not 1 to 1, but
Just a happy accident.
yeah. I like that. We'll keep it at 8. Actually, no, let's keep it at 4, and we're going to add on to that. So this is our base terrain. Now, this other method here, it's the same method. The only difference is I don't create a new line render. All I do is I get that current position and then I add on top of it. That way I can do multiple passes adding stuff to this. So we're going to do another one. Let's see. Let's do 5. We don't want to change these two because that will mess up everything because we only have a static number of points. And then we'll change our scale to, let's change it to 8.
Will it give you a null if you do that, or will it give you a 0 if you do that?
If I give it less points, it'll only modify part of the line render. If I give it more points, it will give me a null pointer exception.
0.
Yeah. So we're going to do add simple. And we didn't get much of a change there. Maybe because our multiplier was set pretty low. Let's go to 10. And we'll just change this to 10 to keep it a little bit different. There we go. So now we get something that's got a little bit more entropy into it. The first one was way too smooth. So we're just going to keep doing this. We're going to take this multiplier down to, let's change it down to 7. Change our scale up to 20. And then we're going to go, let's change our multiplier down to 2 and change our scale up to 60.
So since it's keeping adding, the actual line is also...
The line is moving up.
Right.
Now, you could normalize it. You could take the whole thing and bring it down. Because I'm just adding them together. You could take the max, you could take the min, you could subtract them, however you want to do. So this gives us our 2D terrain for whatever procedural infinite runner, maybe. We could just keep going and adding more line renders to this and then removing the line renders that are behind us and so on. What was the question over here?
I just said worms.
Oh, yeah, there you go, like worms. Now, worms, they actually destroy some of the terrain as well, right? Is that the right?
Yep.
Worms, yeah. So that's a little bit different of a subject because that's using voxels. But so this gives us our 1D terrain for something very simple. Now let's do, let's get rid of this. And the reason I like to do this in the edit mode is that way I could save that specific instance of what I just created.
So do you basically create a prefab out of it?
Yeah, so like this is the prefab that I already had. I didn't even save it, but this is what I generated earlier. And it saves that as a prefab. And then I could even add on to this if I wanted to. I could just, But
How did you generate the points in the editor? Did you generate those? Like the 200 points?
Yeah, that gets generated by this call right here. That position count is a property. So when we set that, the line renderer calls a method to create an array of that many points.
Okay.
That's happening. That's magic happening behind the scenes.
At equal distances in between the two.
Yeah, it'll automatically set that. So that's what created all these positions. I could change that. Let's change this to 50, and I'm going to call it generate simple. And now you'll see here that I have 100 points instead of 200. So it's setting all, and you can see that. You see how it's perceiving these as changes on the prefab. So I could actually just revert this if I wanted to, and I'll get my original thing and back here. So that in the editor you can run any method as if you're running during runtime. Now the update method doesn't happen, of course, but you can manually call methods and create meshes. You can create materials on the fly, which I'm going to do here in a second, and even create textures. So let me delete this one and let me add my other one here, which is a 2D Perlin noise. So I'm going to do this on a quad. So I have a mesh filter with a quad attached to it. And I even have a mesh renderer with no material. And it's going to go ahead and create a material for us, and what we call an instance material. It's also going to generate an error because Unity doesn't want us to do this. So let's edit this. Now, here I have pixel width, pixel height. This is basically the size of our image. And also have our scale. I don't have a multiplier. We could add a multiplier. And then here, the X original and Y original just changes where we are on this map. So if I wanted to generate 0, 0, 0, bam, we got a map for that. Now if I go to the other region, we can just change X. Maybe it's if it's 256 by 256, we wanted to generate the next map over, we would start at 256. And so we can keep generating more and more maps as our character keeps walking. We can just keep generating more and more. We'll just keep this at 0 for now. Let's look at this script. It's a lot like the previous script. The only difference is we don't use a static constant. We don't use a constant. We actually modify both X and Y values. Let's see. I have a generate function here. I'm going to get my renderer. I'm going to create a new texture 2D object. This is a empty texture located in memory. I'm going to create I'm going to create an array to hold all my color values. And then I'm going to go ahead and set the material's main texture to that noise text. I think it wants me to use shared material instead of material, but you can't tell me what to do. So we have our sample value. No, this is our we're going to change the y value and we're going to change the x value. So we have essentially two loops. One to go through our x values and one to go through our y values. And so you can see those getting incremented here. And then just like with the previous example, we're going to start at our x, org, and y. We're going to start at a point, which right now those are both 0. We're going to take x value, we're going to divide it by the width, y value divided by the height. So it gives us always a value between 0 and 1. And then we're going to multiply those by scale. And then I'm just going to take a sample using the mathf Perla noise. Now right here, I'm setting, so when we take that texture 2D object and we set the pixels for it, we can't give it a multi-dimensional array. We have to give it a single dimensional array going across the line. So this is just converting that multi-dimensional array into a single array. Because if you think, if we had something like, if we know the width and height of a multi-dimensional array, so let's say 1, 2, 3, 4, 2, 3, 1, 4, 6, 1, 4, 8. We know this is going to be 4 by 3. We can just take this, we can just write this as 1, 2, 3, 4, 2, 3, 1, 4, 6, 1, 4, 8. Because we know that the column borders are going to be every 4 units. Every 4 units. So knowing the dimensions, we don't need a multi-dimensional array. We can just take that into a single array. And iterating through this is much quicker than iterating through a multi-dimensional array. I'm trying to think, there's a data structure used for that. Can't think of it right now. So this just sets that pixel equal to our sample color. This is just going to give us a grayscale. Going 0, 0, 0, 0 to 1, 1, 1, 1 is from black to white. So this is our main generation part right here. Then all we do is we take our texture, say set pixels equal to the pixel, and then we have to call apply to process that. And then one last thing I do is I write that texture to a PNG file. And with Unity, this is really easy. We just simply take our texture, we encode it to PNG. This is a built-in function. This will give us an array of bytes. And then we say file.write all bytes. We give it a file name, and we give it the bytes. Boom, done.
Now, for, let's say we generated a mesh using the same methods like we did earlier, could you export to OBJ through the same sort of?
I bet you could. Let's ask Unity. Let's ask Google. So I'm guessing there is a package to do that.
Well, actually, I think Unity likes FBX a lot more, but either way, you're exporting the mesh to where you can use it in a different package if you have to.
So yeah, I'm not sure without some type of library. I don't know if it does that. It doesn't seem like that's something that it does that you can just do from a script through like the mesh class. But I'm sure with a library of some sort you could do that. So this is going to create a texture. It's going to get applied to that quad, and then we're going to write to file as well. The reason I write to file is because we want to be able to add on to this here in a bit as well. So let's see, scale 64, let's change it down to 8 and do generate. So there is our quad with some noise on it. Now, going back to that normals, so if I go behind it, there's nothing there. because that back face is not at all rendered. So if we up this, we get noise that's closer together. It looks more like looks a little bit more like random our random noise, but it's not random noise. You can still see that we're getting almost like these wormy little lines here. So something I want to be able to do now. Let me do a refresh. I'll also save this to file. So there's our text file right there. We can even show it in the Explorer and look at it in, our photo viewer. And then you could, go in here and draw all over it and do whatever you want. Do color reassignment, whatever you want to do. Okay, so.
Print it out and tell somebody it's a maze.
Yeah. Print it out. Okay, so. Does this have read, write, enable? We want to do that. This lets us be able to read and write from that texture. That's one step that we have to do when we create this. Okay, so what I want to do is I want a second function. It's already included a load PNG, which just takes the file that I created and loads it back in. So I'm going to create another one here that does the same thing that our first 1D Perlin noise did, which is add on to it. We'll call this add noise. We're still going to get our renderer. We are not going to get our noise texture. That's going to be from our load PNG. So instead of this, we're going to say load PNG, and then we're going to give it where we saved our file at. Let's see. Pix equals new color. So we're not going to do this either. We're going to get that from our noise text. We're going to call it get pixels. We're still going to set this. We're still going to do all of this. The only difference here is this overwrites what's in the value. We want to add to it. So we're going to take this, and we're just going to say, we could just say, we'll do it the simpler way. More wordy, but say that plus our new color. The alternative way to do this is use plus equals, but keep it to as simple as possible. That's our only changes. Yeah, that's our only changes. So instead of creating a new one, we're just loading the texture that we created, and then we're going to add on top of it. We can even do now I'm duplicating a lot of code here, but yeah. Let's do a sub noise. We'll call this subtract noise. The only difference here, we're just going to subtract the value. That way we can just kind of add and subtract all we want. And again, you could do a max. You could do a min. I've written functions for masking so that it deletes everything that's below a certain value. So for creating things like islands, it'll create just a flat portion, and then on that, it only draws on that base plate that I create. Okay, so let it compile, no errors, good thing. Okay, so we already have our texture there. Actually, let's make a better texture to generate. So that gives us some. Well, it's a little bit too close. Let's do 4. Okay, that gives us a little bit of randomness there. So let's change that to 16, and then we're going to add to that. Now, you'll notice there that it does kind of white it out a little bit, so we can do a subtraction. We can even change this up a little bit if we want to add some more randomness to it. And let's do a subtract noise. And again, it's multiple passes. The more, I usually do like 6 or 7 passes to get some kind of realistic terrain. So here, our black parts could be our water level. And then depending on the grayscale value, it will go up from there. So let's do 64, and again, let's change all these values. Let's add on to that. Again, it's a little too bright. Now here's where you really want to have a multiplier. So I can't change the amount that I'm adding. If I had a multiplier, I could say, okay, it'll only add values from like 0 to 0.1 on top. Here it's always adding or subtracting any value from 0 to 1. We'll keep that at 64. Get subtract noise. So here we get, we have our terrain. And actually, I'm going to do another subtract noise. Hopefully this doesn't delete everything out. So that gives us kind of like some islands. So what I'm going to do is this should be saved. Let's create this terrain. So the reason I did it on texture is because then I can take that texture and save it for later. I can put in an art program, maybe modify it. Maybe I want to have something right in the middle, some base terrain right in the middle. I can go ahead and put in an art program, touch it up, whatever I want to do. So now I'm not going to create a mesh because that's a lot of code. So what I'm going to do is I'm just going to create a bunch of primitives, a primitive for each point. So let's create another function here. We'll call this create cubes.
So could you also just create a terrain and set that as the height now?
Yes, you could do that. We could try that actually. That would actually be a lot simpler. I didn't even think about that. Do I have to change anything here?
No.
Okay. So let's create a terrain object.
Ideally, you'd want it to be about the same resolution as the.
It's 256, and that's what
Right.
the terrain is.
So we want to go to settings, change it to 256 and 256. Now the bigger you set your texture, the longer it's going to take to generate. Because you got to think the number of passes can increase very quickly. So 256 times 256, that's 65,000 passes. 512 by 512 is 260,000 passes. So the more you go up, the much more memory it takes. So let's say this takes 2 bytes per thing. So that's 4 megabytes for a 5 by 12 by 512 image. So keep that in mind when you're creating this stuff. So okay, so we want to go. Was it import raw?
Yeah.
Import. Say again. Oh, yeah, you're right. 256. So import raw, go to assets. Oh, wait. It wants a raw file. Let's see what happens if we do this.
I don't think it'll.
Raw files must use a single channel and be either 8-bit or 16-bit. Oh, I don't know. Let's just do it. Boom, import. That did not work. Let's turn off this lighting.
Can you export to RAW from your script?
Maybe. I don't know.
You have to do it in
Photoshop.
yeah.
Okay. Well, let's do this with just a bunch of cubes. Shouldn't be that many. 64,000 cubes. That's manageable. Okay. So in our script, we're going to load in our texture. So let's do this. I'm going to load that in. We're going to go through it. So I'm going to grab this, but we're not going to do any of this. We're just actually going to use this. We're going to traverse it. So let's see here. We got our X value. We just care about the X. We don't really care about anything else. So we got our X value. We got our Y value. we want to grab the value of our pixel. So we're going to say float height equals. We need to set that as well. So let's go back up here and grab this. So we have y, x, and height. We could call this z. Let's call it z just because. And what we're going to do is we're going to say, we'll create a vector out of it first. Vector 3 position equals new vector. X, y, z. This may be turned around a little bit, but that's fine. So we got that. And now we're going to create a cube. Actually, what I'm going to do...
Plot the z by some sort of scale so it's not doing 0 and 1.
Yes. We can do that. So let's add some stuff here. First, I'm going to add a prefab that we actually instantiate. That way we can take the cube and shrink it down if needed. And then we'll do a height multiplier. So here, where are we at? I'm not going to call it, wait, where are we? Create cubes. Okay, so we're going to call this create cubes. Game object, geo equals instantiate. We're going to instantiate our prefab. That way we could make this anything we wanted. Then we set go.position or transform.position equal to position. Oh, and let's take our z value, let's multiply it by our height multiplier. Okay. Because we saved this to file, we don't have to worry about anything in memory. This is already a file, so. Let's see, so we need to fix an error. 116, convert float color to float. Oh, so we only care about one of the values here. Is it RGB? So we can. It doesn't matter. We can just take any one of them. Because like I said, we set that sample equal to all three of those values, right. R, G, and B. So we don't really care about which one we use. Let's see. All right, I'm going to create a really quick cube, and I'm going to change it down to 0.1 size and scale. And we're going to turn that into a prefab. And then in our, we can get rid of that. 2D here, we can put that in our prefab. We'll change our multiplier. We'll start with 5 and see what that looks like. Okay, so I haven't tested this. We'll see what happens. We just created a bunch of cubes. Oh my God, it's a lot of cubes. My browser is...
You need to space them out by the size of the cube as well.
Right.
So let's see what, okay, this looks a little better. So let's see how far apart they are. 114. Oh, that's because they're 0.1. So actually that size of 1 is actually perfect for this. Okay, one thing I'm going to do is I am going to create a, come on Unity, you can delete it.
Still creating more.
Oh God, maybe. I'm gonna crash Unity.
Sometimes I wish when you do something like that, they'd have a, program stop. Stop. Big break.
Let's see if Unity actually is doing anything. Oh man, it's trying.
500 megs in memory.
Yeah, that's fine. We'll just start over. We didn't need those cubes anyways.
He's probably trying to push out that update you make the prefab scale.
Oh man. Oh yeah, I didn't think about that. Okay, let's go back to here. What I'm going to do is I'm going to change the size of the texture to 128 to keep it, okay. So let's put this back in the scene. Let's change this to 128, 128. We're going to have to regenerate this. We'll do something kind of simple. Just generate. Let's look at it. And let's add some roughness to it. And let's move this around. Whoops. And we'll do a subtract as well. Let's do a little bit more. Looks all right. Okay, let's go back to, so we have let's do a refresh, make sure that was fine. Okay, that's good. Let's see here. So again, let's add our cube. So 128, let's see, how many is that? 16,000, that should be fine. Let's add our cube to this. Let's change what we use for our multiplier. 5? Let's do 20. And I could definitely tell that it was on its side. So what if we went through here and changed this to XZY? Let that compile. And let's do a generate cubes. Oh wait, one thing I'm gonna do. I'm gonna create a root game object to hold all this stuff in. So game object root equals new game object called root. And actually what I'm going to do is say old root equals game object find root if old root does not equal null. We'll destroy old root for a new root. For a baby root, little baby root. Okay. And then over here, we just want to set this parent object here. All right. I think that should work. What is this? 125. Oh, there we go. Okay, here goes nothing. Create cubes. Boom. So this is a bunch of cubes, but you can kind of like imagine these cubes all being tied together as a mesh, and then you could even add a water. Actually, let me create a big quad, not under there, and let's give it a color. Oh, I can't do that with default material. Let's create another material. We're going to grade just some simple water material. This is going to be blue, like that. Our quad, we're going to set that to the material. And where did our quad go? Oh, it's right there. Let's lay it on its side. We're going to expand it outwards. And we're going to set that. I'm going to have to expand it a little bit more. So you can kind of think of that as your water. So this gives us our islands, which look like they're kind of mountainous islands. Again, if we actually create a mesh, these would be actually connected together, and we would see peaks and so on. But the code to create a mesh, that would be, it's a couple nights work. So it's a lot of code to show in class. It doesn't take that long, and you can find tutorials out there to do it, to show you how to do it. But it's a lot to do for here.
Question, if you're doing like a voxel game like Minecraft, would you just take that and then just fill extra cubes down? Is that how you have your terrain?
Yeah. So what you would do is, what you do is you actually have chunks. So each chunk will have a multidimensional array in it with a value. That integer value is your block. 0 is air, 1 is grass, 2 is dirt, 3 is whatever. And then you render the chunk as a single mesh. And so you look at each value and you look at the block next to it. If the block next to it is air, you render a face. If the block next to it is another solid block, you don't do anything because no one's going to see that anyways. And so you just render each chunk that way. And then you can even assign a texture to that part of the quad. And you fill it downwards. You could either, if you want to do like a height map where you only know the top portion, like that the game that you saw me working on, where it's more of a height map. You just fill it downwards. But if you're doing full-on voxels, you're going to have a multi-dimensional array, and you're going to look at each individual value. Let me see if I have. We'll save these. Whoops. Calls demo cubes.
You could probably pretty easily do a fill downwards just with the full each front.
Well, I mean, if all the cubes are the same height, you just go down one, create another, go down one, until you reach base level.
Let's see here. So we're creating a cube. We would need to know, we'd have to take that height value, that z value, and we would iterate again from z to 0 and create another cube. Let's try it. For int I equals, now these are,
They should be one by one by one.
call this z height equals z. While z height is greater than 0, we're going to generate a cube, which we can just grab most of this right here, except the position is going to be, let's go ahead and take z height minus equals 1. And let's create a new position vector with z height. That's the song where I say that.
It's going very slow.
And we'll take z position. Okay, instantiate the prefab, set the position, set to that. See how it goes down. Okay, hopefully I didn't create an infinite loop. I'm pretty sure we should be good. It should delete the old root. It should. Let's find out.
Also, this is going to be more cubes than the first attempt. Is that why?
Yes, it is going to be more cubes.
Exponentially.
It's going to be great.
We can actually create something here that says if let's create a water level. Where's our quad is at position 1.9. So if z is less than 1.9, continue. We're going to ignore we're going to ignore anything below 1.9. That's where our water is. Okay, let's see what happens here. 132. We need to rename this to, we'll call this column. Column P. One more. Oh yeah, we can't use the word go. Well, we can just do this. All right. Let's see if this works. So this is incredibly inefficient because we're creating a cube. We're creating cubes that aren't even seen. Normally, you'd want to do full-on voxels and actually look at each side. And you think that it's a very intensive process, but it actually is fairly quick if you're using arrays of integers, not arrays of classes. Like it goes back to that value class. It's much quicker to iterate through primitives like integers and floats and so on like that than it is objects themselves. Let's see. I think we might have crashed it.
Because those previous cubes are still going to be there.
Well, no, I tried to destroy this root.
Oh.
Yeah, but
You should have destroyed it beforehand just to free up the root.
yeah.
Yeah, I think it'd be good to demonstrate this with a lot less of a pixel width.
I want a nice pleasant 8x8 like in the old days.
Yeah.
Unless we were really originally at 16x16.
Oops, I can't do that. Let's create our quad. Put the water on top of it. We'll do that later.
1.7 is 1.9. Don't tell you what I can't do.
We'll fix that later. Let's do 64 by 64. Scale of 4. Let's put our prefab back in here. Height will be, let's do 10. Generate. It's pretty decent. Let's add some more to it. All right, that looks pretty decent. All right, so let's save this first. Actually, I thought we did save it. I guess not. Save scene as demo cubes. Save the project before we do this and do create cubes. I'm pretty sure we have an infinite loop here. But I don't know, it takes z height and reduces it.
Yeah, that's the one.
Put a console logger on these.
The console log will slow it down extremely because it's iterating through a lot of stuff. And actually what it'll do is it'll hang and then it'll print it all out at once because it attempts to try to buffer it.
I mean, an easy way to figure it out would be use a 1 by 1 and see if we'll build a column, just one column.
I think 64 by 64 should be fine.
Well, how high are they? Because it's 64 times 64 times whatever the height of each individual.
Yeah, times 10-ish.
I suppose you could do like a frame inside of your.
Yeah, you can make it a coroutine.
Yeah.
After every column, it waits like 30 frames. That way you can see it progressing through it. So can you fire off coroutines inside the editor?
Can you?
I didn't know.
I don't know.
I didn't even know about the right click menu.
Where nobody has ever gone
Right there.
before.
You can do everything the hard way, it turns out.
Let's go even smaller. Let's do it 8 by 8. That surely should not take that much time. And we'll just do a single pass just to test it. So 8 by 8, scale of 4, generate. These are very few pixels that we have here. Z height is greater than 0. Got our cube, got our height multiplier. And here, yeah, this should be fine. I'm not decrementing anything else. No, I definitely have there's some weird infinite loop stuff going on here. Which is kind of strange because this should handle that. Oh well. But you get the idea. And like I said, using cubes is incredibly inefficient. Let me see if I have my voxel project on here.
I suppose if you want to continue with this to figure out what's wrong, you could actually have it pause every time it creates a cube, so that you wouldn't have to do it through subroutines or coroutines.
Yeah, you could do you could put a breakpoint right after it does a column, like a single column, so you know that one column's done. And then you would know for sure if it's
looping or not.
Yeah, actually, let me do that. Let me open this up. And here, actually, I'm going to do a breakpoint right here just to see how this while loop is going through.
Wow, it's dangerous.
Yeah.
Use a 4.
All right, here we go. It doesn't even hit it.
Question, is Unity frozen? Or
Yeah, Unity is frozen.
it could be maybe your initial Z continued, maybe that just ate everything.
Oh, we hit that. Oh, you know what? We're not wait, no, that shouldn't. Yeah, we need to decrement here, or increment. That's what it was. So this needs to happen up here.
And up down there as well. You cut or copy?
I
What
copied.
did you get for trying to
You
make
said
it?
you cut
What
it.
did you get for trying to make it more
Yeah.
efficient?
Yeah.
I'll teach you.
Actually, you know what? Let's just get rid of this.
Yeah, 1.9 was not really helping me that much anyway, because that's only 2 lines.
I forget my thing is already crapped out here. So we don't do continue. We'll start with that same settings of using just the 8 by 8, just to keep it simple, and then we'll go up from there. So there's our 8 by 8 texture. So actually, it shouldn't matter because we're opening up the texture, not, well, yeah, we're not relying on we're relying on this. Okay, cool.
There you go.
Ta-da. Okay, so that's almost like a single chunk. Like this is some Minecraft stuff right here. Okay, so let's make that a little bit bigger. Let's do
256.
no, not quite.
1024, it's fine.
Let's do a generate. Yeah. I'm just going to delete this manually. And let's do a create cubes. So let's, our multiplier is kind of extreme here. Let's do 5. Let's see if it deletes properly too. It did not. Oh, that's weird. This is a little bit better. Let's go 64 by 64.
Although using this to generate a terrain does not guarantee you that you have a movable path.
It does not. You can create an algorithm to do that though, that tests the terrain, and if there isn't a movable path, it just gets rid of it or modifies, maybe it adds cubes to get to an entry point.
Oh, there it says destroy may not be called from edit mode. Use destroy immediately.
Okay, yeah.
See the console log is useful. What's the greatest part about certain programming languages is that they tell you what you're doing.
Let's do an add on top of it. And let's even do a subtract. And let's create those cubes. So there you go. There you get something a little bit more looking like terrain. We didn't use as much of a height multiplier because that height multiplier really stretches those values out. So there you go. Have an idea, and then we can take our original quad, which was our water quad, and which side are we looking at here? Put that down on the side. Span that outwards. And then you have your water. And then you can move that around depending on where you want your water level to be. Actually, I kind of like it right there. So, and there you go. Just to show you an example, we'll save this scene. Maybe we can post this. I can post this project on like our chat room or something. We have a Slack channel, by the way. Which the Slack, we have to actually send email invites out, don't we?
Yes.
Okay. So I can show you one of the projects I'm working on that uses the same type of Herlin noise. The only difference here is I'm only generating the surface shell, and I'm using cubes, but I'm not using complete cubes. I'm only showing 3 sides of the cube because the camera stays in a fixed position, so I don't even attempt to generate stuff behind it. So yeah, essentially that's it. Here I can even hit play. It's trying to look for updates right now. So in this instance, I'm actually using artistic assets. Many of them provided by Annie over here. But combining those in a procedural manner to give us a scene like this. So again, I have a water level, I have height, procedurally generating all the different. It's taking a long time to run. There we go. Procedurally generating the cubes at each level. I'm only generating the whole, so there's not actually anything underneath it, and it's not voxelized either. It's just a shell.
There's some animals walking around.
There are some animals. The problem is the nav mesh isn't baked in. So there are some downfalls to this. So you can't bake in lighting. because that actually if you're changing the mesh, you could bake in lighting if you're doing it all during design time. But if you want can be completely procedural during runtime, you can't do baked in lighting. And you used to not be able to do a navigation mesh for pathfinding. Now Unity's developing a new navigation components that do allow runtime navigation mesh creating. I didn't get enough time to really look into it, but it looks promising. What was I going to show here? Oh, I was going to bake the nav mesh in real quick. Because it doesn't take that long. So now the animals should properly walk along this ground. There we go. So now the animals are actually walking around and doing stuff. They just kind of wander around and they just eat, and the rabbits apparently jump in place. But yeah. Any questions?
So the nav mesh is just after the terrain gets generated, it goes over all the terrain, determines the walkable areas. Okay. So all this blue area is where agents can walk. So depending on the height, so like this right here the height's too much, but like here, the bricks go up enough to where an animal could actually go up here and walk to here. Only along this path, and so it handles all the pathfinding for you, which is nice. Oh, okay. I thought it skipped a part over there, but yeah. And then from there, you can add nav mesh obstacles where it'll change it in certain areas. And the new, I think they call it a nav surface, is the runtime version of this. This right here, the only way I can actually bake this in is by hitting the bake button. There's no script to call that button. That's the problem there. So I can do these during design time, but I cannot do them during runtime. But nav meshes make, for any kind of like simulation, they make things so much easier. You don't have to figure out pathfinding on your own. So any kind of situation where you have NPCs that are doing their own thing, and you want to be able to figure out how to go to the store on the other side of town, you're going to want to do a nav mesh. Or there are also some other Unity packages out there that do it during runtime, but I would highly recommend doing one of those instead of implementing it by yourself, because it'll take a long time and you're just reinventing the wheel. So. Yeah, and it's anything you do in game development, definitely look to see what's out there that's already been done, just because it's going to save you so much time. It'll save more time, spending a night or two learning an asset than spending weeks trying to implement yourself. Most of the time, yeah. Okay, so that's it. We do have a Slack channel. If you're interested in joining that Slack channel, you can just, if you sign up through Meetup, just post your email in the comments and I'll send you an invite. Okay. Or if it's through Facebook, you can just we have a Facebook page, just Memphis Game Developers. You can actually send us a message with your email. We'll add you that way too. Cool.
Cool.
Thanks.